Creating a website in itself gives a great feeling, and it just gets better when you're doing it using Angular. Hey everyone, welcome back to a whole new exciting session from Edureka. My name is Vajiha, and in this Angular tutorial, you will learn all that you need to know about Angular 8 and also to create your own Angular application from scratch. So our discussion will start with the basic stuff like types of web applications, AngularJS and its drawbacks, the rise of Angular and the differences between Angular and AngularJS. Then, we shall see who uses Angular and why is it so popular. Following that, we shall see what is new in Angular 8, and then I will show you guys how to install Visual Studio Code and Angular on your systems. Then, we shall be creating a project in Angular and see what are the files and folders that are created along with that project. Also, we shall see how this Angular application actually works. Before we move on towards the details of creating an Angular application, you must first know TypeScript. So for that, we shall take a deep look at TypeScript and the building blocks of Angular. After that is done, we shall move on to the most exciting part, that is creating a website from scratch. So before we begin, just make sure you subscribe to our channel and hit the bell icon to stay updated with all the latest Edureka videos. Also, if you're interested in getting an online training certification in Angular, check out the link given in the description box below. So coming back towards this session, let us first see what is web development. Web development is nothing but the development of applications or websites. Professionals who create web applications are known as web developers. These professionals use various methodologies such as Agile to create websites. The applications that were created earlier followed the traditional web applications model. Today, web applications are mostly single-page applications that are compatible both with desktops and mobiles. So what exactly is a traditional web application? If you remember, in the olden days, whenever you would request a web page from a browser, the page would reload for each and every request. These are nothing but traditional web applications. The main problem of this model was the page rendering process, which would happen for each and every request. This was very much time consuming and it eventually disrupted the user experience. To overcome these issues, single page application model was introduced in late 2002. The single page model resolved this frequent reloading issue of web pages, making it much responsive and saving time. So what exactly is a single page application? In a single page application model, the website has dynamic interaction with the user. It rewrites the current page rather than reloading the page entirely. This leads to an uninterrupted user experience. Single-page applications will either load all the necessary code like HTML, CSS, or JavaScript, or just the appropriate resources are loaded and then added to the page if required. Neither is the page reloaded completely, nor will the control be transferred to any other page. There are many frameworks that allow you to create single-page applications. Some of them are Angular, React, Vue, Knockout, etc. However, the most widely used framework is Angular. Angular is actually the successor of AngularJS. So before we move on to see what exactly is Angular, let's take a look at AngularJS. AngularJS is an open source front-end JavaScript framework for creating single-page web applications. It was developed by Google in 2002. There is no doubt that AngularJS was very popular in its time. But AngularJS actually lacked many important features that were being offered by other JavaScript frameworks in the market. AngularJS had a large bundle size, it had performance issues, and it did not support mobile devices. Therefore, to resolve these issues, Angular was created. Since then, Angular has taken over AngularJS, but the Angular community has said that they have extended the support for AngularJS applications until the 30th of June 2021. The rise of Angular. Angular is an open source web application that is maintained by Google. It is based on Typescript language, which is also an open source programming language developed by Microsoft. TypeScript is basically the superset of JavaScript. With TypeScript, Angular introduced an object-oriented programming paradigm into web development. We shall take a deep look at TypeScript, but for now, let us differentiate between AngularJS and Angular. Angular was a complete rewrite of AngularJS. The architecture of an Angular application is different from AngularJS. The main building blocks of Angular are modules, components, templates, metadata, data binding, directives, services, and dependency injection. We'll be taking a look at each of these in a while. Angular does not have the concept of scope or controllers. Instead, it makes use of a hierarchy of components as its main architectural concept. Angular has a simple expression for syntax, focusing on square brackets for property binding and regular parentheses for event binding. Mobile development. Desktop development is much easier when mobile performance issues are handled first. Thus, Angular first handles mobile development. Modularity. Angular follows modularity. Similar functionalities are kept together in same modules. This gives Angular a lighter and a faster core. With TypeScript, Angular has instilled class-based object-oriented programming and static typing into website creation. So who uses Angular and why is it so popular? Angular is widely used by many companies to create their websites. Some of them are Google, Microsoft, Samsung, VMware, Santander, etc. Now there are many reasons why Angular is considered to be the best. Angular is easy to use. Angular allows its users to create full-fledged professional websites with much lesser code when compared to its rivals. The MVC architecture. Angular framework is based on the MVC or the Model View Controller architecture, where the models serve as the base and contain all the data, whereas the views basically deal with what the user sees. Compatibility. Angular works on the client side, which makes it compatible for both desktops and mobile applications. It provides filters. Angular provides filters to filter out different types of data such as numbers, lowercase and uppercase letters, etc. Not just that, you can also design your own filters according to your requirements. Two-way data binding. Angular allows two-way data binding, which means if any changes are made to the models, the corresponding views also get updated accordingly. Not just that, you can also update the models through the views. Now to show you all what this actually is, let me get back to my project. And over here, I'll just click on any of these courses. So as you can see, the name of my course is Python. Now two-way data binding actually refers to changing models from the views and views from the models. So as you can see over here, when I start deleting any of these letters, the name of the course is also getting altered. This is nothing but two-way data binding. We'll get into more details of this later on in this session. Modularity. This is one of the biggest reasons for Angular's popularity. Developers can make use of different modules to create single-page applications. Testing abilities. Angular provides easy and simple testing as a result of module separation feature. Angular is flexible and extensible. Angular is very accommodating when it comes to integrating with the existing technology stack. So what is new in Angular 8? Angular 8 requires the support of Typescript 3.4 for web development. Opt-in Ivy preview. Ivy is the name given to Angular's next-generation compilation and rendering pipeline. This will help you optionally preview your website to see how it works. Differential loading. As a part of its build process, Angular 8 CLI will be able to produce both legacy and modern JavaScript bundles, that is ES5 or ECMAScript 5 or ES 2015 plus. ES 2015 is nothing but ECMAScript 6. This implies a differentially loaded client side with improved speed and TTI, which is time to interactive for present browsers. Backward compatibility of router. Backward compatibility of router helps in simplifying the upgrade path for large projects. Opt-in usage sharing. With this feature, the Angular team will be able to collect anonymous information with your consent to keep a track of the commands that are used and the time taken to build your projects. Dependency updates. Angular 8 has updated the dependencies on tools like RxJS, Node, and Typescript. Now this is actually done for better performance and sync with the current environment. Web worker bundling. Web workers allow you to write code that runs separately from the main thread. This improves speed by parallelizing multiple tasks. The developers of Angular 8 have added bundling support for web workers as a result of requests from various developers. So now let's move on and take a look at the Angular architecture. Using Angular, you can build client-side applications in HTML and TypeScript. Now this is the reason why Angular can implement core and optional functionality of TypeScript from its libraries that you import in your application. The most basic building blocks of Angular are nothing but ng modules. Ng modules basically provide a compilation context for components present in your project. Ng modules will collect all the related code into functional sets. Therefore, it can be claimed that an Angular app is defined by a set of ng modules. Every Angular application will have at least one module, which is the root module. This module enables the bootstrapping process, which I will discuss later on, and typically has many more feature modules. The Angular components actually define views. Views are nothing but sets of screen elements that Angular can select among and modify according to your application's logic and the information that is given. Components in turn make use of services. These services provide application-specific functionality that is related directly to views. Service providers can be injected into components as dependencies, making your code modular, reusable, and efficient. Components and services are nothing but classes, having decorators that are used to mark their type and provide metadata informing Angular how to use them. The metadata for a component class associates it with the template that defines a view. Templates combine ordinary HTML with Angular directives and binding markup that allows Angular to modify the HTML before rendering it to display. The metadata for a service class tells Angular to make it available for other components through dependency injection. Components define many views arranged in a hierarchical order. The router service can be used to define navigation paths among various views of your application, as routers provide sophisticated in-browser navigational capabilities. So moving on in this session, let me show you guys how to install Visual Studio Code. The reason why I'm using Visual Studio Code is because it's lightweight, fast, and open source cross-platform application, and it also has other cool features. To install Visual Studio Code, you can go to the official website and download the version that is suitable for your operating system. Let me just go to the browser. Over here, I'll just type in VS Code, download. So as you can see, this is the official Visual Studio Code downloading website. From here, you can choose any of the versions that is suitable for your operating system and download the installer. Once you're done with installing it on your systems, all you have to do is just complete the setup and it will be ready to use. Since it's already installed on my system, I'm not going to download the installer again. So once you're done installing Visual Studio Code, you'll have to install Angular. The first step is to install Node.js. The reason for installing Node.js is that all web browsers such as Chrome, Firefox, etc. understand only JavaScript. Now all the code that we write in Typescript must be transpiled to JavaScript. The Typescript transpiler requires Node.js for generating the Typescript code to JavaScript. So to install Node.js, you can go to the official website. And from here, choose the version that is suitable for your operating system and download the same. Once the installer has been downloaded, install Node.js on your systems. After you're done with the installation, all you have to do is open up the command prompt. And over here, just type in the command node-v. So as you can see over here, the version of Node that I'm using currently is 12.14.1. So the moment Node is installed on your systems, you'll be able to see the version of it. So I hope you guys are clear till here. The next step is installing the Angular CLI or command line interface. Here, I'll be making use of npm as a package manager which comes along with Node.js by default. Now to install the Angular CLI, all I have to do is type in npm install -g @angular/CLI. The -g over here specifies that I want to install the Angular CLI globally. This is going to take a while. The Angular CLI is actually a command line interface tool that is used to initialize, develop, and maintain Angular applications. We can make use of this tool directly in the command shell or indirectly through an interactive UI or use such as Angular console. I just have a new patch version available over here, so I'm going to run the npm install -g npm command. So now I have the latest version of npm. The next step over here is to create a new Angular project. Now to do that, I'll have to make use of the ng-new command. The ng-new command will be followed by the name of the project. So I'll just take a sample project over here. I'll say ng-new, and I'll just call it sample. And I'll just call it as sample project. Now, when you do this, you will encounter two questions. That is, if you would like to add Angular routing, and what type of style sheet do you prefer? So for the first question, I'll just choose yes and press Y. And for the second, I'm going to choose CSS. So I'll hit enter. However, if you are comfortable with any other style sheet, you can go ahead and select that one. Now, this is going to take a while to create a project. The ng-new command creates an initial skeleton of Angular application by default at the root level of the workspace. Not just that, it also creates end-to-end tests. When you open this application on the local host, you will see that a simple welcome page will appear, which you can modify later on to create your own application. So now our project is created. Now what I'm going to do is just get into my project. So the name of my project was Sample Project. And I'll hit enter. I want to open this project in Visual Studio Code. So I'll just type in code space dot. So now my project is opened in Visual Studio Code. As you can see over here, my project already contains a number of files that are created by Angular. The first is the end-to-end folder. The end-to-end folder contains a source of files to perform set of end-to-end tests that correspond to the root level application along with test-specific configuration files. Next up is the Node modules folder. This provides a set of NPM packages for the entire workplace. The source folder. Source folder contains all the root level application source files that are required for your application development. The edit config folder. The edit config folder specifies the configuration for the code editors. Git ignore. Git ignore specifies the intentionally untracked files that should be ignored by Git. The Angular.json folder. All the CLI configuration defaults for all projects in the workspace, including configuration options for build, serve, and test tools that the CLI uses, such as tslint, karma, and protractor. Next up is the browsers list folder. This folder configures sharing of target browsers and Node.js versions among various front-end tools. Karma.conf.js. This consists of application-specific Karma configuration. Karma is actually a test runner for JavaScript applications. Package.lock.json. Package.lock.json provides version information for all packages installed into Node modules by the NPM client. In case you make use of yarn client, this file will be named as yarn.lock instead. The package.json file. This file configures NPM package dependencies that are available to all the projects in the workspace. The README file. The README file contains introductory documentation for the root app. tsconfig app.json. This consists of all the application-specific TypeScript configurations, including TypeScript and Angular template compiler options. tsconfig.json. This consists of default TypeScript configuration for projects in the workspace. tsconfig spec.json file. It consists of TypeScript configuration for all the application tests. tslint.json. This is an application-specific tslint configuration. So now let me just open the source folder and show you all what's present within this. The first folder that you see over here is the app folder. This folder contains all the component files in which your application logic and data are defined. Next up is the assets folder. Assets contain image and other asset files that are to be copied when you build your applications. Environments. It contains build configuration options for particular target environments. By default, there is an unnamed standard development environment and a production environment. You can define additional target environment configurations if required. favicon.ico. It is nothing but an icon to use for this application in the bookmark bar. The index.html file. The main HTML page that is served when someone visits your site. The CLI automatically adds all JavaScript and CSS files when building your application. So you typically don't need to add any script or link tags. Next up is the main.ts file. The main.ts file is the entry point for your application. It compiles the application with JIT compiler or the just-in-time compiler and bootstraps the application root module. The application's root module is nothing but the app module, which I'll be showing you guys shortly. And you can also make use of the AOT compiler without changing any code by appending the --AOT flag. Now this --AOT flag should be attached to the build and the serve commands in the CLI. Polyfills.ts. This file provides scripts for the browser support. Styles.css. Lists all the CSS files that supply styles for this project. Tests.ts file. This is nothing but the entry point for all your unit tests with some Angular specific configuration. Typically, you don't need to edit any of the code that is present within these test files. So now, let me open the folder that we are going to be modifying in order to create our application. That is nothing but the app folder. The app folder also consists of a number of files within itself. The app.component.ts file defines the logic for the application's root component or the app component. The view that is associated with this component becomes the root of the view hierarchy. The app.component.html file. It defines HTML template associated with the root app component. App.component.css file. This defines the base CSS style sheet for root app component. The app.module.ts file. This is a very important file and it defines the root module named the app module. The app module tells Angular how to assemble this application. It initially declares only the app component. However, as you proceed, when you add on more components, you'll have to specify them over here. So as you can see over here, it consists of the app component. Now when I create more components for this project, all I have to do is come and import it over here. So now that you're aware of all these files, let's move on and create a simple project in Angular. Any website generally consists of HTML, CSS, and JavaScript. HTML basically deals with the content definition, whereas CSS provides the layout. JavaScript actually helps you make dynamic and responsive web applications. So in case you do not have an idea about these, go ahead and check out Edureka's tutorials on the same. So now let's move on and write a simple Hello World program in Angular. So I've created a sample project. Now what I'm going to do is run this project. To run this project, I'll get back to the command prompt. And over here, I'll just type in ngserve. Port 4200 seems to be in use. So in case you guys encounter the same problem, all you have to do is type in netstat followed by -a, -o, and -n. Now this is going to return all the processes that are running on my PC. So what I'm going to do is just find port 4200. So I'll just type in 4200 and I'll find it. So as you can see over here, the process ID that is making use of this port is 3680. Now what I'm going to do is kill this process. To kill this process, all I have to do is come down. So I'll just remember that process ID, it's 3680. And over here, I'll type in task kill /F /PID. That's a slash, not a question mark, sorry. Followed by the process ID. It was 3680. So I'll just type in 3680 and I'll hit enter. So now the process having the process ID 3680 has been terminated. Now when I run the ngserve command again, I'll not encounter the same problem. So as you can see, my project has compiled successfully. Now what I'm going to do is go to my browser and over here, I'll just type in localhost 4200. So as you can see, our sample project app is running. This is a welcome page that is created by Angular. Now to build your projects, all you have to do is go and modify this. So I'll just get back to my project. So what I'm going to do is just open this app component.html file. I'll delete everything present over here except the router outlet. And over here, I'll just give a h1 tag. And I'll just type in hello world. I'll save this. I'll get back to my project and I'll reload this page. So as you can see over here, instead of seeing that welcome screen, all I'm seeing over here is hello world, which I modified in my project. So that was just very basic. We'll get into more details of that later on, but for now, let me tell you guys how this Angular application actually is working. The execution of an Angular application starts from the angular.json file. This file, as already discussed earlier, is used to define all the standards and paths for your Angular project. Also, angular.json file specifies which main.ts and index.html file has to be executed. So as you can see on the screen, I have both the index.html and the main.ts file present in the angular.json file. Now, once this main.ts file is detected, it is compiled as it contains the code that is required to bootstrap or start off the Angular application. From this main.ts file, Angular moves to the app module. So this app module is present in the app module.ts file. So once the main.ts file is executed, it moves on towards the app module.ts file. The app module.ts file consists of all the components that are required by an Angular application. These are the components that Angular needs to know in order to run the application. So in case you create any component, it has to be declared within the declarations array present in the ng module decorator. Angular will check for this bootstrap array, and then it moves on towards the app component. So the app component is present in the app component.ts file. The app component.ts file specifies the selectors, the template URLs, as well as the style URLs. All the components that are present in an Angular application are related to this root component. The app root selector is present in the index.html file. So to summarize it, I can say that the execution begins from main.ts and then it's passed on to the app module.ts file, following which the app component.ts file is executed. So like I've already mentioned before, Angular is built on TypeScript. Before moving on further in this session, I would like you guys to get familiar with TypeScript. In case you're already familiar with TypeScript, you can skip this part and move on towards the next part. Under this section, I'm going to show you guys how to install TypeScript 3.4 and then the basic types that are available in TypeScript, variables, type assertions, functions, classes, and interfaces. So to begin with, let's move on and see how you can install TypeScript on your systems. To install TypeScript, just open up your command prompt. So TypeScript is a programming language that was developed by Microsoft and it is basically a superset of JavaScript. With TypeScript, Angular projects can be created using object-oriented programming model. The TypeScript programming language is designed for development of large applications. However, it needs to be transcompiled to JavaScript as the browsers understand JavaScript only. This process of converting TypeScript into JavaScript is called as transpilation. While using TypeScript, you can make use of any of the JavaScript libraries. Also, any code you write in JavaScript will be valid in TypeScript as you can convert JavaScript code into TypeScript by simply changing the extension from .js to .ts. Also, TypeScript is not platform specific. It can be used on any browser, device, or operating system. So what is the difference between TypeScript and JavaScript? TypeScript is an object-oriented programming language, whereas JavaScript is just a scripting language. TypeScript can support static features, modules, interfaces, etc. But JavaScript, on the other hand, has no support for any of these. So to install TypeScript on your systems, all you have to do is open up the command prompt and then type in the command npm install -g TypeScript. And then you hit enter. So as you can see, TypeScript has been installed on my system. Next up, you're going to check for the version of TypeScript. To do that, just type in tsc --version and hit enter. Okay, I just made a spelling mistake over here. It's a version. So as you can see over here, the version of TypeScript that has been installed is 3.7.5. Now, to write some TypeScript code, you'll have to open up a file in Visual Studio. To do that, what I'm going to do is just type in code, followed by the name of my file. So I'll just say example11. Do not forget to add in the extension that is .ts. So as you can see on the screen, a new file has been opened wherein I can write my TypeScript code. So what I'm going to do over here is simply write one function that is going to return something to the console. So for that, I'll just type in function, which is a keyword, and then this will be a log function, and I'll just pass a parameter, say a. Within this function, I'll have a simple console.log statement, which is going to log something to my console. Next, I'm going to define a, so I'll just say variable a, and I'll just say hello world. Once this is done, I'll have to call the log function. So I'll just say log of a. I'll save this and I'll get back to my command prompt. Now, to convert this into JavaScript, you'll have to call the Typescript compiler using the tsc filename.ts command. So here, the file name is example11. So I'll just type in tsc example11.ts. So now the file has been converted, or the file has been transpiled. So basically, when you do this, the TypeScript code will be converted to JavaScript, but while using Angular, you will not have to do this manually. The Angular CLI will automatically call the TypeScript compiler and perform transpilation when you use the ngserve command. So now if you want to execute this file, you'll have to type in node followed by the file name.js. So I'll just type in example11.js. So as you can see over here, the transpiled JavaScript has returned the output. Now, in case you want to view what is present in that example.11.js file, all you have to do is just type in code example11.js. Okay, so as you can see, here is the transpile code. The code that we have written is in TypeScript, but the code that has been transpiled to JavaScript is present in example11.js file. So I hope you guys are clear with this. In case you have any problems with the functions or the syntax, do not worry because I'll be covering each of these later on in the session. So the first thing that I'm going to be discussing over here is the basic types that are present in TypeScript. TypeScript supports almost the same data types that are present in JavaScript. These can be Boolean, numbers, strings, arrays, tuples, enum, any, void, null and undefined, never, object, and type assertions. Now, in case you're coming from JavaScript background, you guys will be very much familiar with the var keyword. But please make a note that in TypeScript, it is better to make use of the let keyword rather than the var keyword. The let keyword was included in JavaScript in ECMAScript 2015 and is considered as a standard as let is much safer compared to var. So now let's move on and take a look at each of these. So the first basic type that I'm going to be discussing over here is the Boolean data type. As many of us know, Boolean data type refers to true or false values. In TypeScript, it is preceded by a Boolean keyword. So before writing down the Boolean type, what I'm going to do is show you how to declare the types in TypeScript. So the first method is to make use of the var keyword followed by the identifier and then a colon symbol, the type of variable followed by an equal to sign, and then comes the value. So this is the first method. The second one is much similar, but you can omit the value present over here. So I'll just copy this, paste it over here, followed by a semicolon. The third way is to simply specify the value without specifying the type. So I'll just copy that. And instead of type, I'm going to have the value. And instead of the colon symbol, will be an equal to symbol. The fourth method is declaring neither the value nor the type. In this case, the data type of that variable becomes any, which means you can initialize any type of value to that variable. So I can just have a variable followed by the identifier and then a semicolon. So these are the four methods in which you can declare variables in TypeScript. So before this, we were actually talking about Boolean. So in case I want to create a variable holding Boolean values, all I have to do is type in let. I'll call the variable as b. I'll specify the type to be Boolean. And I'll give the value as false. So as you can see over here, Visual Studio will also give me details about what this actually is. So when I hover over b, it says that b is a Boolean type variable. So in case I want to print out the value of b, all I'm going to do is type in console.log b. I'll just save this. I'll get back to my command prompt. And the first thing that I'll have to do is colon tsc exm.ts. Sorry, I just made a mistake in the name of the file. It's exm2. Okay, so now my file is transpiled. Now to execute this file, all I'm going to do is just type in node, file name that is exm2.js. Okay, so as you can see, the value is false. The next basic type that's present in TypeScript is numbers. So in TypeScript, numbers are nothing but floating point values, and TypeScript supports all types of numbers such as octal, binary, hexadecimal, etc. To declare any of these, you can make use of the number keyword. So in case I just change the value from Boolean to number, and this will not be false, this will be some value, say 10. And I'll just change the name of the variable, I'll say call it C. And then instead of logging B, I'll log C. Okay, so now let's transpile our file. And then I'll type in node exm2.js. Okay, so as you can see, the value of C is 10. In case you want to specify hexadecimal, octal, or binary values, you can do it in a similar manner. So let me just take an example of a hexadecimal value. So I'll just type in let d, which is a number, equals 0, 0, 1, 2, 3. So this is an example of an octal value. The small o that you see over here specifies that this is an octal value. Similarly, if you have to specify binary or hexadecimal values, all you have to do is change this by b or x. So now let's move on towards the next type, which is strings. Strings are used to work with textual data. In TypeScript, you must use string keyword to specify them. Say for example, I have a variable, say name. So I'll type name, colon, string. I'll just change the variable name since I've already declared this before. So I'll just call it as first name rather. This is going to be a string, and I'll just specify the name as Edureka. Okay, so this is how you specify strings. Now in case you want to execute this, all you have to do is get back to your command prompt, transpile your file, and then make use of the node command followed by the name of the file .js to execute this. So now moving on towards the next basic type, which is arrays. TypeScript supports arrays just like JavaScript. You can declare them in two ways. The first is to use the type of the element followed by square brackets or an array, or specify them within angular brackets. Okay, so I'll just clear this from here. And I'll take two new variables. I'll say let AA be an array of string type. So string followed by square brackets. Now for the values, I'll just specify TypeScript and JavaScript. I'll just say TS followed by JS. Okay, so this was the first method. The second method was making use of the angular brackets. So I'll just type in let AB, which is a new variable, followed by the array keyword, and then I'll open up the angular brackets and specify the type. And then you can pass in the values. You can specify any values of your choice. So this is how you declare arrays in TypeScript. So I hope you guys are clear with this. Next up are tuples. Tuples are types that can also be used in TypeScript in case you have to define arrays with fixed number of elements whose data types are known, but they can be different. So this means I can have any variable. For example, let AC be a tuple of numbers and strings. So I'll just say number, the first element, and string as the second element. So here I know the type of data that this tuple is going to hold, but it's not going to change over time. Okay, so the next type that I'm going to be discussing over here is enum. Enum in TypeScript allows you to define a set of named constants. Okay, so if you guys are wondering what are constants, constants are variables whose values cannot be changed. Say for example, I just type in const, which stands for constant. I'll declare a variable ad, and I'll specify its value to be 10. So what happens when I do this? When you make use of the const keyword, the value of this variable, which is ad, will not be changed over time. So if you guys are wondering when you should actually use this, you must make use of const for all those variables whose value you wish to preserve and not for the others. The idea is that if a variable didn't need to be modified, someone else working on it should not do it. By using the const keyword, the code becomes foreseeable and helps in reasoning out the flow of data. So now the enum type. Enum in TypeScript allows you to define a set of named constants. Using these enums, you can make document intent easily or even create a set of different cases. In TypeScript, you can use both numeric enums and string-based enums. Enums are defined using the enum keyword. So let me take an example of a numeric enum. So what I'm going to do is just type in enum, which is the keyword, followed by fruits. And then I'll just call this enum as fruit. Now what I'm going to do is specify some values within this. So the first value is going to be apple, and I'll equate apple to 1. Now I'll discuss why I'm doing this later on. Now let me take another fruit. I'll say banana and mango, and finally an orange. Okay, so this is how you declare an enum. The numeric enum that you see over here has apple initialized to 1. The other members are auto-incremented, having the values 2, 3, and 4. In other words, fruit.apple has the value 1, banana has 2, mango has 3, and orange has 4. However, it is not necessary that you have to specify any value to this. In case I just remove this value, then apple will be initiated to value 0, banana would be 1, mango would be 2, and orange would be 3 respectively. This auto-incrementing behavior comes in handy when we do not care about the member values but do care that each member has a distinct value in that enum. In case I want to return the value of any of these, what I'm going to do is just type in console.log, and over here, okay, before this, I'll just take a new variable, or I'll just call it as fruit name. This is going to be a string, and then I'll just call fruit of 2. And then I'll log the fruit name. Let me just save this, get back to my command prompt, and over here, I'll transpile this file. So now to execute it, I'll just type in node exm2.js. Okay, so as you can see over here, the fruit that is initiated to 2 is mango. Okay, so I hope you guys have understood this. Okay, so now moving on towards the next type, which is any. The any type is used when you do not know what is the data type of the element. This usually happens when you're dealing with dynamic values and you do not want to encounter compile time errors in case the type of the element generated is not as that you assumed. The any data type allows you to opt in and opt out of type checking during compilation. So in case you want to declare a variable of any type, all you have to do is just type in let, followed by the name of the variable, and specify any. So now the variable ag can hold any value such as numbers, strings, etc. So over here, if I just specify ag equals 10 and also ag equals a string, say Edureka, you can see that it's not showing any errors. But in case I change this from any to say number, you can see that when I assign a string to this, it throws an error. Okay, so I hope you guys are clear with this. Now moving on towards the next type, which is the object type. The object type basically represents a non-primitive type in TypeScript. This means it can be any type which is not a number, a string, boolean, symbol, null, or unidentified. In case you want to declare an object variable, all you have to do is make use of the let keyword. Let me just clear this. Specify the name of the variable and then type an object. So this is how you declare object types in TypeScript. So before moving on further, let me clearly differentiate between the let and the var keyword. So what I'm going to do over here is just create a function, and then I'll specify some name. I'll just call this as myfunc. And within this, I'll have a for loop. And first I'm going to take the var keyword or the var keyword. So I'll say variable I, initiate it to 1 until I is less than or equal to 2, and then I++. Okay, so until this condition is met, what I want to do is just log the message saying welcome to Edureka. So I'll say console.log, and I'll type in the string, which is welcome to Edureka. So after that is done, I'll take another console statement, and I'll just type in the final value of I. Now I'll come out of this function, and I'll call this function. So now let me just save this, get back to my command prompt, and execute this. So as you can see over here, the string welcome to Edureka has been returned 2 times. This is because the value of I at first was 1, and until the value of I is less than or equal to 2, I wanted it to print the string welcome to Edureka. So therefore, welcome to Edureka printed twice, followed by the final value of I. Okay, I have not specified the final value of I. Let me just do that over here by specifying a plus sign and then I. Sorry for that. I'll retranspile it and execute the function. Okay, so here it is. The value of I is 3. So now let's see what will happen if I change this var to let. So I'll just erase this and I'll type in let. Okay, so as you can see over here, the scope of I is not going beyond this for loop. The I that is present outside this for loop throws an error. So I hope you guys have understood this. Now this is why the let keyword is considered to be more safer than the var keyword. I is visible only within the for loop, which is the nearest block, and if you try to access it anywhere outside it, it is not possible. However, even if you compile it after changing from var to let, the compiler will compile it and convert it into JavaScript. The JavaScript file can be executed to return the corresponding output. So let me just save this, get back to the console, I'll clear the screen, and I'll transpile this file again. Okay, so as you can see over here, it has thrown an error saying cannot find the name I. So I hope you guys are clear with this. So now moving on towards something very important, with is type assertions. When you declare some variable with a type, you will see that TypeScript will assist you on all the available methods that you can use along with it. But TypeScript also allows you to declare a variable without specifying its type. So what I'm going to do over here is just take an example. So let me just take a new variable. I'll say let my variable, which is of type string, hold some value, say Edureka. Now, the moment I specify my variable followed by a dot symbol, you will see TypeScript has given a list of all the functions that I can use along with this variable. Now, in case I do not specify the type of this function, so what I'm going to do is just delete this. And then when I type in this function followed by a dot symbol, you will see that this is of any type and it does not give you any suggestions. Now, in this case, you will need to explicitly specify the method that you want to use. If you still want TypeScript to assist you, you can make use of type assertions. Type assertions will help you specify the type of variable even if you have not specified them while declaring it. Now, type assertions can be done in two ways. The first is to make use of the Angular brackets. So what I'm going to do over here is take another keyword. I'll say let, take another variable. I'll say my variable 2, and this will be of number type, to which I'll specify the string value of my variable. So within this, I'll just take the Angular brackets. I'll specify the string type, and I'll just call it my variable. Previously, when I typed my variable followed by a dot symbol, TypeScript was not assisting me since this is of any type. Now, I've specified that this is of string type. The moment I type a dot symbol along with this, you will see the TypeScript is assisting me again. So this was the first method of specifying type assertions. The second method is to make use of the as keyword. So instead of this, what I'm going to have is my variable as a string. So I hope you guys are clear with this. So that was about type assertions. Now moving on towards the next topic, which is functions in TypeScript. Functions, as we all know, are the building blocks of a program. Functions allow you to build up different layers of your program that deal with abstraction, information hiding, etc. In TypeScript, functions play a very important role in describing how to do tasks. Another advantage is that TypeScript also adds some new capabilities to standard JavaScript functions to make them easier to work with. In TypeScript, you can create functions both with a name or as anonymous functions, just like JavaScript. This will let you choose most ideal approach for your applications. So now let's create a function over here. I've already taken a few examples before. So I'll just take a function, say product, and I'll pass in two variables as parameters to this. And then open up the curly braces. And within this, I'll just have a single return statement that is going to return the product of X and Y. Okay, I've made a spelling mistake over here. So this is how you create functions in JavaScript. You type in the function keyword, followed by the name of the function and the parameters. Then you'll have to specify all the statements that come within this function within curly braces. Now, in case you want to call this function, simply specify the name of the function along with the parameters. I'll just say 2, 3. So now to run this file, all you have to do is get back to your command prompt, type in tsc followed by the name of the file, and then node followed by the name of the file.js. Similarly, if you want to create nameless or anonymous functions, I'll just type in anonymous over here, and then I'll make use of the let keyword. I'll take a new variable, and to this I'm going to assign the value that is returned by a function. Now this function is actually a nameless function or an anonymous function. Sorry guys, I have to specify an equal to sign over here. I'm going to have the same return statement for this as well. So now let me just save this. And before executing this, I'll just type in console.log of w. So now let me get back to my command prompt and execute this. So as you can see over here, I have the value of 4 star 6, which is 24. So I hope you guys are clear with this. Functions can also refer to those variables that reside outside the function body. Let me just delete this from here. So what I'm going to do over here is declare a new variable outside this function's body. So I'll just call this variable to be y, and I'll specify its value to be 3. Now what I'm going to do is return the product of x star y. I'll give this a different name. I'll call it as z rather than y. So this time I'll return the product of x star y star z. And then I'll call the function. So as you can see over here, I have the value returned as 45, which is a result of multiplying 3 cross 5. So I hope you guys are clear with this. You can also add type to a function. In case you want to add some type to it, all you have to do is just specify the type of variable that you want to give over here. So in case I want to specify x to be a number, I'll just say x colon number and y colon number. You can also have different types. So instead of y having number, you can also have it as a string or anything else. So now talking about something very important, which is arrow functions. Arrow functions are somewhat like lambda functions of Python, C#, etc. These functions can be defined in just a single line. So to specify an arrow function over here, let me just take a new variable. I'll just call this variable as ex. I'll open the parenthesis. I'll take in a variable a. I'll specify the variable a and then the arrow function, and I'll just log the value of a. So over here, my variable ex over here holds the value of what the function has returned. A over here is the parameter and the action to be performed is console.log. So now I'll just get back to my command prompt. What I'm going to do is just transpile this file and I'll just open the JavaScript version of this. Okay, so as you can see over here, this is the Typescript function that I've written. Now, when I open the JavaScript file, you can see that it is much more bulkier compared to that of the Typescript file. Arrow functions are very useful in terms of reducing the code size. Plus, they can also be served to other methods as inputs. If my function has no parameters, you can also specify them without any parameters. So in case you do not have any parameter, simply leave empty brackets like this. So I hope you guys are clear with this. So now moving on towards classes in TypeScript. TypeScript introduced classes so that they can avail the benefits of object-oriented techniques like encapsulation and abstraction. The class in TypeScript is compiled to plain JavaScript functions by TypeScript compiler to work across platforms and browsers. So a class in JavaScript can include constructors, properties, and methods. Now it's very important that you guys concentrate on this part because we're going to make use of this syntax in our project later on. So what I'm going to do over here is just create a class. So I'll just type in the keyword class and I'll name this as my class. Next up, I'll open the curly braces. Within this, I'll specify a class property. I'll just take a variable j of number type. Now j is nothing but a property of my class. So next up, I'm going to have a constructor. And within this, I'll take a new variable, say k. And this is also going to be of number type. You can give any types of your choice. I'm just taking this for instance. Within this constructor, I'll just have a simple statement. So I'll say this dot value of j is equal to k. Next, I'll declare a function. Let me just call this as value. And within this, I'll have a simple return statement that says the number is plus this dot my variable or this dot j. So that is done. Now let me come out of this class. So my class is ready. But as we all know, to access any of the variables or functions present within this class, I'll have to create an object of this class. So to create an object, I'll have to make use of the new keyword. So what I'm going to do is just take an object name. I'll say my object equals new, which is the keyword to create an object, followed by the class name. So my class. My class constructor has one parameter over here whose value I'll have to specify. So I'll just specify the value as 6. Next up, I'll make use of the console.log statement, and then I'll make use of the object, which is my object, dot value, which is the function. Okay, now let me just execute this code. So as you can see, I have the output as the number is 6. So basically, my object over here is accessing the function that is present in my class, and then it returns the corresponding value. TypeScript classes also support inheritance. Inheritance is the ability of a program to create new classes from an existing class. The class that is extended to create newer classes is called as the parent class or the superclass. The newly created classes are referred to as the child or the subclasses. A class inherits from another class using the extends keyword. Child classes inherit all properties and methods except the private members and constructors from the parent class. Another point to be noted over here is that TypeScript does not support multiple inheritance. So what I'm going to do is just create a new file over here. So I'll type code exm3.ts, and over here I'll just type in the syntax of inheritance. So what you have to do is make use of the extends keyword. So I'll have the class child followed by the extends keyword and then the parent class. So what I'm going to do is get back to my previous example, and from here I'll just copy the first half of this code. Let me just change the name of this class. I'll call it as new class or a parent class. Now, in case I want this to be a parent class, what I have to do is make some other class inherits this. So I'll just take another class. I'll call it as child or child class. Please make a note that the first letter should be in caps. I'll do it over here as well. This is nothing but convention and it's better to follow it. So the child class actually extends the parent class. So within this, I'll specify some new variable, say L, and this is also going to be of type number. It can be of any type though. Next up is the constructor, variable M of type number. Now this is specific to the child class. Now what I'm going to do is make use of the variable that is present in the parent class. K is the parameter that is present in the parent class. The reason why you're seeing all these red lines over here is because I've not made use of the super keyword. So what I'm going to do over here is type in the super keyword, and I'll specify the parameter that I've taken from the parent class, that's K. So as you can see, all the red lines have disappeared. And I'll also type in this. Okay, so that is done. Now I'll create a value class within the child class, and I'll return the value of K and the value of M. So I'll just type in the value from parent is plus this dot J plus, and the value from child is plus this dot L. So that's it. I'll come out of this function. I'll create an object of this class. I'll say new object and the name of the class, which is child class, and I'll pass in the values as 12 and 23. And then I'll make use of the console.log statement. And I'll call the value function using this. So this is how you create child classes in TypeScript. You can also make use of access specifiers in TypeScript. They can either be public, private, or protected. For example, if you make the parent class variable as private, you will see that an error will be shown in the child class. So I'll just get back to my class over here, and over here, for this property, I'll just specify this as to be private. Now, when I type this.j over here, you can see that TypeScript is throwing an error. You can also see the message that says property j is private and only accessible within the parent class. Similarly, if I change it from private to protected, you will see that the error disappears. Now this is because protected members are visible to child classes as well. Private members are accessible only and only within the class and nowhere else. So now let's move on towards TypeScript interfaces. An interface is a structure that will contain only the declaration of fields and methods, and there'll be no definition of it. When some class inherits an interface, that class has to define each of them within the class itself. I'll create a new file over here. In case you want to define an interface, you'll have to make use of the interface keyword followed by the name of the interface. I'll just specify the name to be my integers. Within this, I'll have a few variables, say s, which is a number, t, which is a string, and then a function. I'll just call it as my function. Okay, so as you can see over here, none of these have any values assigned to them, nor does my function have any definition. Now, in case some class implements this interface, it will have to specify values to s and t and also redefine my function. So let me just take a class. I'll call it as class A. To make use of that interface, I'll have to use the implements keyword. So implements my integers. So the reason why you're seeing an error is because class A has not redefined anything present within the interface. So the moment I redefine everything present in the interface, the error will disappear. So what I'm going to do is type in s number and t, which is string, and then I'll take a constructor of this class to which I'll pass in the same values, that's s and t. So this dot s is s and this dot t is t. And then I'll redefine the function, which is my function. So as you can see over here, the moment I've redefined each of these, the error has disappeared from here. So over here, I'll just type in console.log, implementing an interface, and then I'll return the value of both these variables. That's s and t. So I'll type in this dot s plus a space character and this dot t. Now I'll create an object. Let object say o equals new, followed by the name of the class, which is a. And then I'll have to specify two parameters to this. The first is s, which is a number. The second is t, which is a string. So for s, I'll just say 1. And for the string, I'll just say hi. Okay, so that is done. Now I'll make use of the console.log statement again. I'll say o dot my function. Okay, let me just save this, get back to my command prompt, and transpile this file. Sorry guys, I've executed the inheritance example. So I'll just transpile the file wherein I've written this. So I'll just say tsc, that's ex4.ts. So as you can see over here, the values 1 and hi have been returned. So I hope you guys are clear with this. So now let's get back to Angular. So the next most important thing that you'll have to know is the building blocks of Angular. The building blocks of Angular are modules, components, templates, metadata, directives, data binding, services, and dependency injection. Modules. A module basically allows you to separate the functionality of your program into different parts. These parts are independent of each other, which means each module's outputs are completely separate from that of the other. If you make changes to any of these, the change will be made only to that module and it will not interfere with those of the others. In Angular, modules will allow you to group together other building blocks such as components, directives, pipes, and services. The modules of Angular are referred to as ng modules. Applications created by Angular are driven by functional sets which collect related data. Therefore, Angular apps are defined by a set of ng modules. Ng modules are very much different when compared to those of the JS modules or the JavaScript modules. Ng modules declare a group of files that can be parsed and analyzed. You can also make use of other ng modules within one by importing them. Above all, these modules prove to be very much helpful when you're creating large applications that have multiple functionalities. Besides allowing clean creation, these modules also help you minimize the code size by reuse and optional import of the required ones. This is also referred to as lazy loading, meaning you can load any ng module only on your demand. Not to forget, ng modules are also one of the biggest reasons for Angular's popularity. Every application created with Angular will have at least one ng module, which is the root module. This root module is referred to as the app module. So by default, the app module will look something like this. So let me just get into the project we created initially to show you all what this app module looks like. So as you can see on the screen, this is the default app module that has been created by Angular. It is present within the app module.ts file. The import statements that you see over here are basically JavaScript imports. The class that follows has an ng module decorator. Decorators basically modify classes or property definitions. They are also referred to as annotations and are JavaScript features. In Angular, these decorators contain some metadata to classes and properties so as to convey what they mean and how they are supposed to function. I shall explain what is metadata in detail later on when we reach the component section. Here, the ng module decorator first identifies the root module or the app module and then tells Angular how to launch and compile it by making use of the metadata. The declarations that you see initially are the application's only component. Imports are used to import the browser module to attain browser services as DOM, sanitization, rendering, etc. Providers are nothing but the service providers, which we shall be discussing later on. Bootstrap is the root component created by Angular and it is inserted into the index.html host web page. So I hope you guys are already familiar with this because I've already explained this earlier while discussing how an Angular application actually works. The app component is present both in the declarations and in the Bootstrap array. This app component is created by the Angular CLI or the command line interface for every default application. The declarations array present in the module informs Angular about the components that belong to that module. When you create more and more components to your application, all you must do is add them over here. Components cannot be used without declaring them in the NT module class. So make sure you declare every component you create exactly once in the NT module class. If you fail to do so, you're sure to encounter an error. The declarations array can also contain declarables or components, directives, and pipes. All the module's declarables should be present in the declarations array and they must belong to just one ng module. The classes that are declared within one module are visible only to that module, but they can be exported to other modules. In case you've defined some other component, you will have something like your component, your pipe, etc. For now, I've not created any of these, so let me just remove this from here. So apart from this, the ng module can also contain exports. Exports are the subset of declarations that are accessible in the component templates of other ng modules. Components. As mentioned earlier, Angular applications have at least one component, which is the root component. This root component connects the component hierarchy with the page document object module or the DOM. All components define classes that have the application's data and logic, and they also are associated with the HTML template. This HTML template defines the view that is to be displayed. Therefore, components are basically used to control the views of an MVC architecture. The component decorator will tell Angular that the class immediately below is a component and provides the templates and related component-specific metadata. Angular components are the most basic UI or the user interface for your application, and they always are associated with a template and are a subset of directives. The component's logic is defined inside a class. This basically determines how it supports the view. Components are created, updated, and deleted by Angular as you proceed in your application. Your application can take action at each moment in this lifecycle through optional lifecycle hooks such as ng-on-init. Lifecycle hooks provide visibility into the key life moments and the ability to act when they occur. Therefore, lifecycle hooks allow you to control the component's runtime behavior, and they are called only when they are defined. Angular provides a number of lifecycle hooks such as ng-on-changes, ng-on-init, ng-do-check, etc. ng-on-changes will respond to Angular's resets data-bound input properties. The method receives a simple change object of current and previous property values. It is called before the ng-on-init method and whenever one or more data-bound input property changes. ng-on-init. The ng-on-init hook initializes the directive or the component after Angular first displays the data-bound properties and sets the directives or the component's input properties. It is called once after the first ng-on-changes method is invoked. ng-do-check. ng-do-check will allow you to detect and act upon changes that Angular can't or won't detect on its own. This function is called during every change detection run. There are many more lifecycle hooks that you can check out for yourself in the official documentation. Okay, so now moving on towards the next building block, which is metadata. The metadata of a component informs Angular of all the building blocks required to create and present the component along with its view. To be specific, it links templates with the components either directly with inline code or by reference. The component along with the template describes a view. The selector that you see on the screen is a CSS selector that tells Angular to create and insert an instance of this component whenever it finds the corresponding tag in the template HTML. Template URL, the module relative address of this component's HTML template. Alternatively, you can provide HTML template inline as a value of the template property. Providers. The providers array is nothing but an array of providers for the services that the component requires. So what exactly does a template do? Templates are somewhat like HTML that inform Angular how to render the components. As mentioned earlier, Angular views are created in a hierarchical order, and the template that is immediately associated with the component defines the component's host view. The hierarchy of views will not just contain views from components of the same module, but also those of the other modules. The template syntax. As mentioned earlier, templates are very much like HTML, but they have Angular template syntax. In Angular, component can be a controller or a view model, whereas the templates represent views. Having HTML in templates. Angular template make use of HTML, but the script element is an exception. It does not allow this tag in order to eradicate the risk of script injection attack. If you make use of it, the tag gets ignored and a warning will be raised by the browser console. However, some HTML tags like HTML, body, base, etc. make no sense in Angular. Everything else, however, can be used. Interpolation and template expressions. Through interpolation, you can add strings into the text that is between HTML element tags and within the attribute assignments. The template expressions can be used to calculate these strings. Interpolation syntax. Strings can be added using interpolation by specifying them within double curly braces. However, you can make use of this in different places for different requirements. Angular actually converts interpolation into property binding. Another benefit of making use of Angular is that it allows you to configure the interpolation delimiter and use something of your choice instead of the two curly braces. To do that, all you have to do is go to the interpolation option in the component metadata. Template expressions. Template expressions are present within two curly braces and they produce a single value. Angular will execute the expression and then it assigns it to a property of a binding target such as HTML elements, components, or directives. Okay, so now moving on towards the next building block, which is data binding. If you do not make use of a framework, you'll have to push data values into HTML controls, turns user responses into actions, and also value updates. Obviously, it is very irritating to write everything, plus it will be prone to errors and will be horrible for someone else to analyze the code. Using Angular, you can perform two-way data binding, which is a mechanism that coordinates the template along with the components. All you have to do is add some binding markup to the template HTML in order to inform Angular how to connect with both these sides. There are basically 4 forms of data binding markup, and each of these has a direction. They can either be to the DOM, from the DOM, or both. Okay, so moving on, let's discuss in detail about property binding. Property binding is actually one-way binding. In property binding, value flows in one direction, that is from the component's property into the target element's property. It can be used to read or pull data from the target elements. In the same way, property binding cannot be used to call a method that belongs to the target element. The events raised by elements can be acknowledged only through event binding. Event binding. Event binding, on the other hand, will allow you to listen to certain events such as mouse movements, keystrokes, clicks, etc. In Angular, event binding can be achieved by specifying target event name within regular brackets on the left of an equal to symbol and the template statement on the right within quotes. So as you can see in this example over here, I have the target event name, which is click, and then the template statement. Whenever event binding occurs, an event handler will be set by Angular for the target event. When the event is raised, the handler executes the template statement. This template statement usually involves a receiver that performs an action which is in response to the event. For example, storing a value of an HTML control into a model. Binding is used to convey information about the event. This information can have data values like event object, string, or a number. Okay, so now that you guys are aware of both property binding and event binding, let me tell you guys what exactly is two-way data binding. I've already given a small introduction about this previously. So two-way data binding allows your application to share information between a component class and its template. In two-way data binding, there are 2 things can happen in two-way data binding. The first is setting a specific element property. The second is listening to an element change event. Angular offers a special two-way data binding syntax for this purpose. Two-way data binding can be specified within a combination of brackets, that is square brackets outside and parentheses inside. So it's going to look something like this. You're going to see all this shortly when we're actually creating our application. Okay, so now let's move on towards pipes. With Angular pipes, display value transformations can be declared in your template HTML. A class with the @pipe decorator defines a function that transforms input values to output values for display in the view. Angular has various types of pipes such as uppercase pipe, lowercase pipe, date pipe, currency pipe, etc. Not just that, you can also define your own pipes as well. So as you can see over here, this input line is an example of two-way data binding. Now it is because of this line that I was able to manipulate the name of the course plus see the changes in the name itself. This button click over here is an example of event binding. The course ID that you see over here is interpolation or property binding. Okay, so I was actually talking about pipes. Now you can see over here that I've specified some value within the interpolation brackets, and then I've made use of a pipe in order to convert it to uppercase letters. So all the course names will be changed to uppercase. Not just this, you can also chain pipes sending the output of one pipe function to be transformed by another pipe function. A pipe can also take arguments that control how it performs its transformation. So now moving on towards the next building blocks, which is services. A service is a broad category that encircles values, functions, or features that are required by an application. Service classes have a narrow and well-defined purpose. Components are differentiated from services in Angular so as to increase the modularity and reusability of your code. Separating the component's view-related functionality and other kinds of processing will make your component classes lean and efficient. Components are also supposed to present properties and methods for data binding in order to function as a medium between view, which is rendered by the template, and the application's logic, which generally includes some notion of a model. Component can delegate their tasks to services, say for example fetching some data from a server, validating user input, or logging outputs to the console. By defining such processing tasks in an injectable service class, you can make use of those tasks available to any component. Applications can also be made more adaptable by injecting different providers of the same kind of service. By making use of this class over here, I'm going to send a message to the console whenever a course detail has been fetched. Okay, so what is dependency injection? Dependency injection can be used by new components to provide services or other things that they need. Components basically consume services, that is, services can be injected into a component, giving that component access to service class. You must make use of the injectable decorator to provide the metadata that allows Angular to inject it into a component as a dependency. Similarly, you can also use the injectable decorator to indicate that a component or any other class, say for example a service, a pipe, or an ng module has a dependency. The injector is the main mechanism. Angular creates an application-wide injector for you during the bootstrap process, and additional injectors are needed. You actually do not have to create injectors. An injector creates dependencies and maintains a container of dependency instances that is reused if possible. A provider is an object that tells injector how to obtain or create a dependency. If you need any dependency in your project, you must register a provider with the application's injector so as to follow the injector to use the provider in order to create new instances. For example, the provider is typically the service class itself. In my project over here, the course list that I've shown you all earlier requires a course service. So this is basically my course service. Whenever Angular sees some component that is dependent on a service, it will first check if the injector has any existing instance of that service. If the instance does not exist, the injector will create one using the registered provider, and then it adds it to the injector before returning the service to Angular. Once all the services that are requested have been resolved and returned, Angular can call the component's constructor with those services as arguments. Okay, so now let's move on towards directives. A directive in Angular is basically a class with the @directive decorator. The Angular templates are dynamic. When they are rendered, the DOM will be transformed according to the instructions given by the directives. A component is technically a directive, but components are so distinctive and central to the Angular applications that Angular defines the @component decorator separately. This actually extends the directive decorator with template-oriented features. In addition to components, there are two other kinds of directives. They are structural and attribute directives. Angular defines a number of directives of both these kinds. The metadata for a directive associates the decorated class with a selector element that is used to insert it into HTML. In templates, directives typically appear within the element tag as attributes, and that can either be by name or the target of an assignment or a binding. So what exactly are structural directives? Structural directives are used to alter the layout by adding, removing, or replacing elements in the DOM. For example, the ng-for directive. Let me just open my project and show y'all where it's present. Okay, this ng-for is nothing but a structural directive. This directive will allow a list of elements to my console. Attribute directives. Attribute directives will allow you to alter the appearance or behavior of existing elements. In templates, they look like regular HTML attributes, just as the name says. The ng module directive that I've shown y'all earlier, which implements two-way data binding, is also an example of an attribute directive. This directive modifies the behavior of an existing element by setting the display value property and responding to the change events. So I hope you guys have a clear idea of each of these building blocks. Now it's very important for you guys to know this, because while creating your applications, you'll have to make use of each of these building blocks. Okay, so now let's jump on to the most exciting part, that is creating an Angular application from scratch. So like I've already told y'all before, make sure that your development environment includes Node.js and an npm package manager. To check the version of Node on your systems, you can type in the command node-v. I've already shown this before, but I'm doing this just for reference. So as you can see, I have Node version 12.14.1. The first step before creating a project is to install the Angular CLI, like I've already told you all before. Once you're done with installing Node, you'll have to install Angular CLI on your systems. To do that, you can make use of the npm install -g @angular/CLI command. So that is npm install -g for global @angular/CLI. Once that is done, you can create your new project. So to create a new project, you should make use of the ng-new command, followed by the name of the project. I'll just name it as AT or Angular tutorial. And this is going to take a while, guys. The first question that prompts is, if you would like to add Angular routing, just say yes and hit enter. You'll see another question that prompts, which asks you which style sheet format would you like to use. In this case, I'm going to use the CSS style sheet. So therefore, I'll hit enter for CSS. So now a project has been created. The next step is to get inside your workplace. To do that, you just have to type in cd, followed by the name of the project. In my case, the name of the project is AT. Okay, so once this is done, I'll have to serve this project. The Angular CLI includes a server so that you can easily build and serve your app locally. Now to run your project using that server, you can simply type in ng serve -open. This ng-serve command will launch the server, it will watch over your files and also rebuild the app as you make changes to it. -open is optional, and when you use this, it automatically opens your browser to the localhost 4200. So as you can see, the development server has automatically opened. The page that you see is the welcome page, and in order to build your application, all you have to do is modify this. So now I'll get back to my command prompt and I'll just type in code dot so that I can open this in Visual Studio Code. Okay, so as you can see, a project has been opened. Earlier in the session, I've already told you guys what each of these files does. Now what I'm going to do is just open up the source file, get into the app folder. So the source folder is the basic folder where I'm going to manipulate stuffs in order to create an application. So I'll just open app-component.html page, and over here, I'll select everything except the last line, and I'll delete it. So now, let me just write a simple statement within the h1 tag. I'll say welcome to Edureka. So now I'll just save this and see if my project is still working. Okay, so as you can see over here, previously I had the default welcome page of Angular, and now it's changed to what I have typed in my app-component.html file. So it looks great. So let's go ahead and build our project. Okay, so this is a very basic application. The next thing that I'm going to do over here is create new components in order to display the information that I want my app to show. So to do that, I'm going to create the first component of my application. I'll get back to the command prompt. I'm terminating the development server. It's better to do so because if you keep the server running and then you create a component, you'll have to close it and rerun your program again so that Angular gets to know that a new component has been installed. If you do not do this, you will see an error saying that the component you created is not found. So what I'm going to do over here is type in the command ng generate component followed by the name of the component. So that is ng generate component. And since my basic component is the courses, since I'm creating a template of the Edureka website, my basic component will have the courses of Edureka. So what I'm going to do is just name it as courses and I'll hit enter. Okay, Angular has created 4 files. The first is courses.component.html. Second is courses.component.spec.ts file. This file is basically used for testing purpose and we're not going to be manipulating this in our project today. Next up is the courses.component.ts file. And then you have your style sheet, which is the CSS file. Now this CSS file is particular to this component, which is the courses component. So now let's get back to our project and see how these files actually look. Here is the component that I created. Let me just increase the size. Okay, so as you can see, here is the component that I've created, and these are the files. The first file that I'll open over here is the component.ts file. Now, before starting off, Angular has already written the basic code. Now, I want you all to note that this component symbol has been imported from the Angular core library, and then it is annotated to the component class. The @component decorator, like I've already told y'all before, will specify Angular's metadata for this component. So what are selectors, template URLs, and style URLs? I've already explained to y'all earlier in this session. So just a brief about them. Selector is nothing but the component's CSS element selector. Template URLs tell the location of the component's template file, and style URLs specify the location of the component's private CSS style sheets. This function, which is the ng-on-init function, is a lifecycle hook like I've already told you all before, and Angular calls this function shortly after creating a component. It's a very good place to put initialization logic. Now the reason why this class has been exported is because it can be imported anywhere else and therefore you will not have to rewrite the code. Okay, so next what I'm going to do is add a course property to the courses component present in my class. Okay, so I'll just type in course and I'll name this course as Angular itself. Next, I'll have to show this course. So what I'm going to do is just open up the courses component.html file. I'll replace the statement with an interpolation property that specifies the course. So let me save this. Do not forget to save any changes you make to your project. To display the courses component, you must add it to the template of the shell of app component. Now you must remember that app courses is the element selector for the courses component. So to add an app component element to the app component template file, all you have to do is open app-component.html and over here, just type in app courses. Okay, so I hope you guys are clear till here. So now let's get back to our browser and see how it works. Let me just refresh this. I had actually terminated the process. So what I'm going to do is just type in the ngserve command again. In case you had not terminated this process and you're trying to reload the page, and if you see any errors, just terminate the process like I've already shown you all earlier in this tutorial how to terminate a process. Terminate the process at port 4200 and then rerun your server. Okay, so as you can see over here, I have the course name which is Angular. Previously, I just had one statement which was welcome to Edureka. So the next thing that I'm going to do over here is create a course class. So next, I'm going to create a new file over here, and I'll just name it as course.ts. In this file, I'll create an export class named course that is going to have the ID number and the name of the course. So I'll just type in export class followed by the name of the class, that is course. It's going to have two properties, that is the ID, which is of number type, and name, which is of string type. Okay, let me just save this and then return to the course component.ts file. And then I'll have to import the course class that I just created. So within these import statements, I'll write import the name of the class, which is course, from ... followed by the name of the file. I've forgotten a slash over here. So now I have imported the class. So I'll just come back to this course component class, and over here I'll initialize the ID number and the name of the course. So let me just delete this. This course property is going to be of the type course class. So I'll just type in course equals the ID number. I'll just specify it to be 1 and the name. Okay, so let me just save this. So now I'll jump on to the component.html file, courses component.html file, and update it over here. So I'll just create a tag. I'll say h2 tag, and within this I'll open up the interpolation braces and I'll specify the course name. So that's course.name. Next, I want to specify the course ID as well. So what I'm going to do is just create a div class. I'll just open the div tag and the span tag, and then I'll just type in ID and specify course.id. I'll just copy this line and I'll do the same for the course name. So now let me just save this and get back to my browser and see how it works. This is a very common error, guys. When you encounter any of these, just get back to your command prompt and run the ngserve command again. So I'll just terminate this and I'll rerun ngserve. Okay, I'm sorry guys, I should not specify a semicolon over here. Okay, so here it is. I have the name of my project followed by the ID number, and then I had specified the name of the project again, so you see it over here. Now the reason why I specified the name of the project over here is just to show you guys how to make use of a pipe. So I'll get back to my project, and within the course component.html file, in the first place where I've specified the course name, I'll just add in a pipe and I'll make use of the uppercase pipe. Now this is going to change all the letters present in the course name to uppercase. So I'll just save this, get back to my project, and the project has reloaded. Now the name of Angular is displayed in blocks. Okay, so I hope you guys are clear till here. The word uppercase that I'm using over here is a form of interpolation binding. It's coming right after the pipe operator. So this is how you make use of pipes in Angular. Pipes are a very good way to format strings, currency amounts, dates, etc. And Angular ships with several built-in pipes, and you can create your own as well. So since I'm the admin user, I should be able to manipulate the name of the course as well. The text box should be able to display the course name property and update the property as I give the input. This means that the data will flow from the component class out to the screen and from the screen back to the class again. To automate this data flow, you can set up two-way data binding between the input tag and the course.name property. Okay, so what I'm going to do is open the course.component.html file, and over here, so in place of span, I'll just use label, and then I'll make use of the input tag, and then the two-way data binding syntax, ng model, followed by the course name and the placeholder. The placeholder in this case is name, so I'll specify name slash. I'll just save this. I don't need this anymore, so I'll just remove it off. This ng model is Angular's two-way data binding syntax. Here, it binds the course name property to the HTML text box so that data can flow in both directions. That is, from the course name property to the text box, and from the text box back to the course name. Okay, Now when I try to run this on my development server, you will see that it will not show me any output. I'll just refresh it and show you guys. So as you can see over here, it's not showing any output. Now this is because I have to add ng module as it is not available by default. I'm going to open up the app.module.ts file. And over here, I'm going to import, or I'll simply copy this. I'll import forms module from the Angular/forms library. The ng module is actually contained within this library. Now once this is done, I'll have to import it within the import array as well. So I'll just type in a comma over here, and then I'll import the forms module. Okay, now I'll save this. I'll get back to my browser and reload it. Okay, so as you can see over here, an input text box has been created. Now when I try to manipulate any of these, you can see that the corresponding change is represented in the name of the course. Okay, so I'll get back to my project now. The next thing that I'm going to do is declare the course component. Every component must be declared exactly once in ng module. So if you guys have noticed one thing, I did not import this course component class manually over here. What I've done over here is already installed an auto import package. So let me just show you guys auto import. Okay, so this will automatically find, import, and pass the required code in your project. So it's better if you guys install this, you will not have to manually import anything that is required by your application. And the moment you create any component, it is going to be imported by default. The next thing that I'm going to do is create a mock courses file. What I'm going to do is create a list of courses within this mockcourses.ts file, and then I'm going to display it on my console. The file that I'm going to create will lie within the app folder. So I'll just right click, select new file, and I'll name this file as mockcourses.ts. Now within this file, the first thing that I'm going to do is import this course class present in the course.ts file. So the first statement over here is going to be import the name of the class, which is course. Okay, so as you can see, I've imported the course class from the course file. Next, I'm going to create an export class, and this is going to be constant. The name of this class is going to be courses, and this is going to be of the course class type. And since it's going to hold more than one values, it's going to be an array. I forgot to specify the square brackets. Okay, so within this, I'll have key value pairs where the keys will be the ID and the name, and the values will be the corresponding ID numbers and the names of the courses. Okay, the ID of the first course is going to be 01, followed by the name, which is a string, and the name of the first course is going to be C++, for example. I'm supposed to specify an equal to symbol, guys, so that is why I'm getting the error. Okay, so the ID is 1, name is C++. So similarly, I'll specify a few more courses. I'll just copy this. I'll change the ID numbers and the names. This is ID 2, 3, 4, 5, 6, and 7. I'll just change the course names as well. Okay, so now I've specified a list of courses, and I'll just close this and I'll save this file. If I have to display these courses, I have to get back to courses.component.ts file. And over here, I'll have to import the courses class that I just created. So I'll just type in import, the name of the class. So as you can see, the moment I type what I want to import, it's auto imported in my file over here. This is because of the auto import feature. So let me just remove this and save it. Okay, next thing I'll have to do is make changes in the courses component class. Okay, so what I'm going to do is replace all this, and I'll simply say that the property courses is of type courses, which is the class. Instead of colon, I'll have to specify an equal to sign. Be careful with these minor things because it's going to make a major impact. So now I'll open the courses.html file, and over here, I'm going to make some changes. I'll just remove this, and within the h2 tag, I'll just say courses at Edureka. And then I'm going to specify a list. So what I'm going to do is just remove this. I'll create an unordered list. And this is going to be of the class type courses. Next, I'll have to specify the list tag And then I'll use the span tag within which I'll specify the class as batch and then the interpolations symbol. Within this, I'm going to specify the course ID and then I'm going to specify the name of the course. Okay, so once this is done, I'll just save this. Okay, so this is going to return one course. To list all the courses, I'll have to make use of ng-for. ng-for is Angular's repeater directive. It repeats the host element for each and every element that is present in the list. The courses list should be attractive and should respond virtually to the user when he hovers over the course list. To do that, you could add more style to the styles.css file and keep growing that style sheet in order to match your specifications. So you can add in any CSS that you want over here in order to display your output as per your requirements. Okay, so now what I want to do is enable the user to see the details of a course when he clicks on any of the course that's present in the list. Initially, I'll be displaying the details of this course at the end of the page. So to do that, I'll have to add a click event. Now the click event, like I've already told y'all, is a type of event binding. So before I make any more changes to this HTML file, I'll get back to the courses.component.ts file, and over here, I'm going to make the required changes. So the first thing that I'm going to do is add a selected course component. I'm going to add a selected course property, and this is going to be of the type course. After this, I'm going to create a new function, and the name of this function is going to be onSelect. So onSelect of course, which is of type class, that is course class. The return type is going to be void. And within this, I'll just return this dot selected course. And this will be equal to the course itself. Okay, so now this is done. I'll just save this. I'll get back to my HTML file and make the corresponding changes. Okay, like I've already told y'all, I'm going to make use of ng-for. So that comes within the list tag. The ng-for will be preceded by an asterisk symbol. So ng capital F for. Now let course of courses, and then within square brackets, I'm going to specify class dot selected equals course triple equal to selected course. Okay, so now I'll create a click event over here. So when you click on any of the selected courses, I'll have to call the onSelect function. And this takes one parameter, which is the course itself. Okay, so now that is done. Okay, I'll just remove this list tag from here. So now my courses.html file is ready. In case the user selects any of the course that's present in the list, I want to display the details of it. Now to do that, what I have to do is include ng-if. So I'll specify that within the div tag. Just like ng-for, even ng-if is going to be preceded by an asterisk symbol. So if any course is selected, I'll specify an h2 tag, and within this, I'll specify the name of the course in caps. And then I'll just say that these are the details. Within this, I'll create another div tag and span selected courses ID, and then the name of the course itself. So now I've made all the required changes, and I already have some CSS ready for this. I'll just copy paste that from my previous files. Okay, so now I'll just save this. So let me just show you guys the final code. So here it is. I have a for loop, then I have an if condition. I'll have a list of all the courses that I've specified within this mock courses file. Plus, if I select any of these courses, I'll have the details of that course displayed. Let me get back to my development server. So as you can see over here, I have a list of all the courses. And when I select any of these, I'll have the details of that course revealed over here. So as you can see, as and how I select the courses, the details get updated. So now what I'm going to do is create a separate details page for this course details. Instead of displaying all the details At the end of my page, I'm going to create a separate component that will hold the details of each course, and it will display the details of the course when the course is selected. So what I'm going to do is get back to my command prompt. I'll just terminate this and I'll clear the screen. So now I'll type in the command ng generate component followed by the name of the component, which is going to be course detail. And I'll hit enter. A new component has been created with the 4 files, that is the HTML file, the test file, the component.ts file, and the component.css file. So now I'll get back to my project. And what I'm going to do is just cut this part. And I'll open the details file or the details.html file. And I'll paste it over here. Rather than making a single congested HTML file, all I've done over here is created a separate component which is going to hold the details of the course. So now I'll go to the course detail.component.ts file, and over here I'll have to import the course class. The course property must be an input property, and it should be annotated by an input decorator. Now this is because the external course component will have to bind it. So I should add another import statement over here, wherein I'm going to import the component on init and the input functions. So I'll just type in import. I'm not going to type in separately over here. All I'm going to do is add it in within this statement itself. So I'll just say comma input. So next up, what I'm going to do is add in the @input decorator within the course detail component class. So I'll specify @input decorator, and this is for the course, which is of the course class type. So now my details.component.ts file is ready. I'll just save this. So now I'll get back to courses.component.html file, and over here I'll have to specify the course detail binding. So what I'm going to do is just include app course detail. Within this, I'll have to specify the course property, and the target is going to be selected course. This course property specified within the square brackets is an example of property binding, like I've already told you all before. The property binding that I've specified over here is one-way data binding between the selected course property of the courses component to the course property of the target element. This will map the course property of the course detail component. So let me just save this. So now, in case the user clicks on any of the course present in the list, the selected course will change. When the selected course changes, the property binding updates the course and the course detail component and displays the new course. So now let's get back to our browser and see how this works. I'll just refresh this. I'll have to rerun the server. So as you can see over here, my browser has reloaded. The moment I click on any of these pages, I'm supposed to see the output of the details of that course over here. Now, when I select any of these courses, I'm not able to see the details of it. So let me get back to my details.html page. Okay, so here it is. So it's not supposed to be selected course, it's just course. It is because I'm referring to the course property, unlike the selected course property of the previous example. So I'll just change that everywhere. It's going to be course. Let me just save this, get back to my browser, and rerun it. So now, if I select any of the course details, the details are displayed at the bottom of this page. One thing I want you guys to note is that previously, these details were rendered by the same component, that was the courses component. Now, these details are rendered by the details page rather than the courses component itself. So the next thing that we are going to do over here is add in some services. Components shouldn't fetch data or save data directly. They should focus on presenting data and delegate data access to a service. In this tutorial, I'm going to show you guys how to create a course service that all application classes can use to get the courses. To do this, I'll be relying on the dependency injection of Angular. Services are a great way to share information among classes that do not know each other. Here, I'm going to create a message service and inject it in two places. That is the course service, which uses the service to send a message, and in the message component itself, which will display the message. So what I'm going to do is get back to my command prompt. I'll terminate this and clear the screen again. Next, I'm going to write ng generate service, and the name will be course. Okay, I've made a spelling mistake. It's servic. So now our service class is ready. So what I'm going to do is get back to my project. I'll open up the newly created service.ts file. Here, I'll have to import the course class. So I'll just type in import the course class. And also, I want to import the courses class. So both are done. Next, I'll be adding the get courses property. This property is going to be of the course type. So within this class over here, I'll type in get courses, which is of the type course itself. And within this function, I'll just have one return statement that is going to return the courses. Okay, I'll just save this. So once this is done, I'll have to make the course service available to the dependency injection system before Angular can inject it. For that, I'll have to register a provider. A provider, like I've already told you all before, is something that can create or deliver a service. In this case, it's going to instantiate the course service class to provide the service. So as you can see over here, Angular by default registers the provider with the root injector for your service by including the provider metadata. When you provide the service at the root level, Angular creates a single shared instance for the course service and injects it into any class that asks for it. Registering the provider in an @injectable metadata allows Angular to optimize an app by removing the service if it turns out not to be used after all. So the next thing that I'll have to do is get back to the course component.ts file. So now I'll have to import the course service. And then I'll just save it. So next, I'm going to remove the selected course property. And I'll make the previous one as an array. And this will be of the type course. To add a private course service parameter of the course service to the constructor, all I'm going to do is go on to this constructor and I'm going to specify private and the name of the service, which is course service. And this is of type course service class. So this parameter will simultaneously define a private course service property and identifies it as a course service injection site. When Angular creates a course component, the dependency injection system sets the course service parameter to the singleton instance of course service. Now I'm going to add another method over here. So I've made use of the selected course property. So what I'm going to do is just include it over here. Sorry for that, guys. I deleted it thinking that I have not made use of that property. The next thing that I have to do over here is include another function, and this is going to be the get courses function. I'll just specify the type of it as void. So within this, I'm going to have an arrow function. So if you do not know what is an arrow function, just get back to the part where I'm explaining arrow functions in Typescript. So this .course service .get courses function subscribe and the parameter, which is courses, this .courses. I'll shortly be telling you guys why this error is appearing over here. I'll have to make a small change in my code and this error is going to disappear. So I'll get back to the course service.ts file, and over here I'm going to import observable and off from rxjs. Just delete this line. So within this get courses function over here, I'll be making a small change. I'll just include observable of the type course. And over here, it's going to be return of courses. Okay, so now the error should be fixed. Okay, so as you can see over here, I don't see an error anymore. The of courses over here will return an observable course that emits a single value, and that will be the array of mock courses. The observable function will emit an array of courses. The subscribe method passes the emitted array to the callback, which sets the component's course property. So now I'll just save this. Next up, I'm going to generate another component, which is the messages component. So I'll get back to my command prompt, and over here, ng generate. And this is a component, messages. Okay, so I have a new component named messages in my application over here. Now this component will actually display the application's messages at the bottom of the screen. Since I've created a new component over here, I'll have to get back to the app.component.html file, and I'll have to include it over here. So I'll just specify app. I'll just save this. Okay, so now when I get back to my browser and rerun this, I'll have to run the server again. Okay, so now let's get back to our browser. Okay, so as you can see over here, my browser says that messages is working, which means that this component is working fine. So the next thing that I'm going to do over here is create a message service. So I'll get back to my command prompt, and I'll specify ng generate service messages. Okay, so now let's get back to our project. Within this file over here, which is messages.service.ts file, I'll create a property, which is messages. It's going to be of the string type. And for now, I'll just keep it as an empty string. Next, I'll be creating an add function. To this, I'll add the message, which is of the type string. Within this, I'll just have a single statement, which is this dot messages dot push. I'll just say message. Okay, I'll specify another function within this. I'll add a clear function, and then this dot messages equals an empty array. Okay, so now I'll save this. Now what I'm going to do is inject this into the course services. So I'll open the course service.ts file, and the first thing that I'm going to do is import the message service. Now I'll come down to the constructor present in the course service class, and I'm going to modify it. I'll just say private message service is of type messages service. Okay, so the next thing that I'm going to do is send a message from the course service and then display the message from the course service. Okay, what I'm doing over here is just modifying this getCourse class. I already pasted the code that I have, so I'll just delete this and I'll save it. So here it is. I've actually not retrieved the courses, so I'll just specify this dot get courses, and that's a function. I'll save this, and let me check if I've missed anything else. This is fine. Get courses, then subscribe courses. Okay, here is another step that I've missed. So this is equal to the courses itself. Now I'll save this. I'll get back to my development server. Okay, so here are the list of courses. One thing that I've not done is I'll open messages component.ts, since this is the main file. Okay, here it is. I've not included messages service over here. So what I'm going to do is just import it, message service. And the next thing that I'll have to do is specify a public parameter that I'm going to name it as message service. And this is going to be of type messages service. Now I'll just save this and I'll get back to my browser. Okay, so now my messages component is working. So the moment I click on any of these, I'll have the details plus a message will be added over here. Okay, so now let's get back to our project. The next thing that we'll be doing over here is routing. In Angular, The best practice is to load and configure the router in a separate top-level module that is dedicated to routing and imported by the root app module. By convention, the module class name is app_routing_module and it belongs to the app_routing_module.ts class. Now, in case you have to generate that, all you have to do is get back to your command prompt. And over here, you'll have to run the command ng generate module, ng app routing, followed by -flat -module equals app. Okay, looks like I've already created it earlier, so I don't have to create it again. However, let me just tell you that --flat puts the file in the source app instead of its own folder. --module equals app will tell the CLI to register it in the imports array of the app module. Okay, so let me just get back to my project and check for it over here. So that's app routing module. So here it is. So this is the default app routing module that is presented by Angular. So I'm going to modify this file in order to suit my project. So the first thing that I'm going to do over here is import course component, and I'm going to modify this constant routes variable. And then I'm going to modify this constant routes variable. So within this, I'll just specify a path. So the path will be first courses, and then the component is going to be course component. Okay, so now I'll just save this. At first, the app routing module will import router module and routes so the app can have routing functionality. Next, the course component will give router somewhere to go once you configure the routes. A typical Angular route will have two properties. One is the path and second is the component. A path is nothing but a string that will match the URL in the browser address bar. Component is the component that the router should create when navigating to this route. This will tell the router to match the URL to the path. Okay, so what I'm going to do over here is get back to my command prompt. And over here, I'll type the command ng generate component. And I'll just call this component as home. Or rather, I'll call it as dashboard, which I've shown you all earlier. So as you can see over here, a new component has been created. Instead of typing the code manually over here, I'll just copy paste it and I'll explain it to you guys later on. So here is the modified app routing module.ts file. This line over here is importing the router module to the imports array. And also, it configures it with the routes in one step by calling the router module.forRoute method. The method is called as forRoute because you configure the router at the application's root level. The forRoute method supplies the service providers and directives needed for routing and performs the initial navigation based on the current browser's URL. Next is the export router module. Now this is to make this router module available throughout our application. So now let me just open the app_component.html file. And over here, you've already seen this router outlet present. Now this was already done because during the initial stages of the project, when we were creating the project, there were two questions that were asked, among which the first one was if you want to add routing to your project. And there we had specified yes. And therefore, this was already included in the app_component.html file. I just want you guys to note this router link over here. Basically, my project has two pages. The first is the dashboard and second is the courses page. The dashboard is nothing but the home page and the courses page will consist of a list that contains all the courses that are available. So now let me just show you all the dashboard file over here. So here is the dashboard. It contains 4 of the top courses. ng4, like I've already told you all before, is a repeater and it creates as many links as the component's courses array. So let me just open this app routing module.ts file. So over here, an empty path means that this is my dashboard. If there is no extension or an extension having dashboard, it is going to be my homepage or my dashboard. Next, when I select any of these courses, the path will be redirected to detail plus the ID of that course. So let me just show this to you guys. I'll open my project. So over here, when I click on any of these courses, so it's redirected to the details page of that particular course and the details of that page. So over here, we are specifying the detail plus the course's ID as the path. Next up is the path courses, wherein we make use of the course component. Let me just get back. The moment I select this courses at Edureka, you will see a list of courses that are available over here. So that were all the 4 parts that are available in my project. So this brings us to the end of this project. I hope you guys have enjoyed and learned something new. In case you have any doubts or queries, please do let me know in the comment section and I will revert to you at the earliest. Goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!